Yes, thank you, Mr. Aditya. So let's start the masterclass. So welcome you all. Good afternoon to all of you, and I hope all of you are enjoying the monsoon season. So in the series of the masterclasses that the Solar Lab has designed, so as to increase the awareness of the solar, not only in the EPC players or in the shareholders, but also in the general public and in the awareness in the conscious of the general public. So this is another lecture in the series, and let me introduce myself. So my name is Ayush Ragwal. I'm a mechanical engineer by education, and as of now, I'm working as an account executive at the Solar Labs. The aim of the Solar Labs is to improve the pace of solar rooftop adoption, not only in India but all around the world. We are a IIT Mandi startup. We started in the year of 2017, and after doing a 2-year extensive research with the industry and knowing the supply and demand gap of the industry, in the 2019 we have launched our product, the Solar Labs, and as of now we have a good success. We even in the COVID times we have been able to achieve 500 plus customers, not only just in India but in our neighboring countries, the SAARC region, as well as in the Egypt, Turkey, Dubai, and we are launching soon in the USA also. So that was all about me and my company. If I tell you something more, so we are the first AI-based solar designing platform. We help EPC players to increase their sales. All our previous customers who we have taken feedback from have accounted that 10% of the sales have increased by using our softwares. It's because on the account of the easy designing, good generation numbers, as well as easy platform, a single platform, so no repetition of work is needed. A layman, even a technician, even a salesperson can easily design on a software, and no other person is required. And that has helped accelerate the solar rooftop adoption in India. And now we are seeing that more and more projects are coming every day. Now, the aim of the masterclass, as I have already told you, the aim is to share the industrial knowledge, present market needs and trends, what are the new things that are coming, and how a layman can be a stakeholder in the solar development to make people aware of the climate change that's happening, and how we can tackle it, as well as to introduce the web-based training to boost market of AI technology, as well as having a live interaction with our customers as well as with the lay people. General solar softwares that are available in the market are SketchUp, Solar Labs, AutoCAD, PVSys, and Helioscope. I will not get into the details of every software as of now, but we will looking in the series to look into every of the softwares, see their pros and cons, and then a person can decide which software is the best and can choose among them. Today, I am only going to show you how to design in the Solar Labs, and in the future, if the time permits, we can go into other softwares also. Now, a question may arise in your mind: why do we use solar softwares? We use solar softwares first of all to cater ourselves to the new needs that are coming. So the first one is for interactive 3D designs. More and more customers are demanding how their roof will be looking once the installation is done. Whether we will be getting some space, how is the will it affect our rooftop in any sense? People demand are increasing, and as an industry player, we should also cater to their needs. The second is the shadow analysis. It's a typical task to do shadow analysis, and especially for residential areas where the buildings are high rise. There can be high rise building on the left hand side, right hand side, before and after. There's a big can be some trees. There can be some objects like cylindrical tanks, some empty, some cabins, and we need to know whether we should place the panels so as that in less amount, in the least amount, we can get the maximum production. So as to optimize our designs, we need shadow analysis to know how much generation we are going to produce, to know what's our payback period, how much we will be saving, whether it's advisable, it's intelligent, it will be a wise decision to go and invest our money, our hard-earned money into this project or not. All this thing can be told by financial simulation, and generation analysis aids into it. Automatic SLD and automatic CAD layout helps again the designer's work to get reduced. Automatic CAD layout and automatic SLD can be given to the engineers, electrical engineers, as well as the installers, and they can use it to aid themselves in designing as well as in laying the cables. The reports formed are professional and can be easily understandable to the general public, and it saves stable labor, time, and money. To show you some of the features, this is the shadow analysis. I will be showing you all of the features in a live demonstration. All of these features also. The first one is the shadow analysis. To give more emphasis on the shadow analysis, I just want to point out to this thing that here you can see that the cylindrical object shadow analysis is way different than the shadow generated by a polygon. So here you can see the two polygons of the same size, one cylindrical, one square. You can see what the shadow pattern is coming. This is the shading that we are getting due to these high-rise buildings. All these plants are being generated by me myself, and I am just showing you some of the designs that I feel myself that has helped our customers a lot. So I have designed these sites while I was interacting with some of my customers, and there you can see that because of this mumpty or cabin, you can see that installing panels on these much panels should not be placed. These are not just going to increase the finances and can also reduce the whole generation if we are going for stringing in this sense. For the same thing, we have the solar access map. I will be telling you all about these things once we go into the software itself. This is the CAD layout that is generated by me, 3D designs, and all other things. So let me take you to the software now. So to go to the software, just simply go on to the Google. Here you can type the solarlabs.com and hit enter. And boom, we are to the page. We are on the home page of the Solar Labs. So it is a software which is cloud-based software. You don't need to install this software. This software doesn't take a bit of your hard disk. It runs only, you need only a decent configured laptop or a PC and a good internet connection, and you are all ready to go. You just have to type their login credentials as you type your login credentials in Facebook or in Gmail ID, and then you are ready to design your softwares, to show your designs, to make new designs anywhere in the comfort of your home, in the comfort of your office, or on the site, or to your client at their home or at their location. So here we have an interactive map. This is a projects page. So on the left hand side we have an interactive map. Here you can see all these sites have been designed by me and my colleagues all over India and all around the world, and you can reach to any of the locations just by clicking on the site and going on to the edit, or you can simply go and search for the dashboard, or you can search here. So if you know the project name or the client name, you can search here, or you can go directly onto the dashboard and choose any of your existing project that you have already created. To create a new project, you have to go and click on this blue icon, and here you will be asked to give the latitude or longitude of the site. So in our software, unlike other software, you just don't need to give only the latitude and longitude. You can go also a site. If the building's name is popular, you can just type the building's name also. So for example, if I want to go and design on BL Life Sciences, I just have to type BL Life Sciences. And again, you can see that all the BL Life Sciences buildings that are all around the world have been there. They are on my search bar, and I can choose any one of them. So I intend to design on the site of Greater Noida. So I have chosen here. I will adjust it by zooming in or zooming out so that it fits inside the box. In the left hand side, I can give the project name and the client details. So if I give the project name as BL Life Sciences, the client details as Mr. Ayush, my name myself, and all these details that I'm typing in here will be reflected in the report that I will be downloading. So here I hit confirm, and here we have reached to the project summary page. On the right hand side I have the location where I need to design, and on the left hand side I have the project and the client details. During or after the designing, whenever I want, if I have done any mistake or I want to edit some of the informations, I can simply go into the edit and enter new information, And when I hit confirm, all these information will be reflected into the report of the first page. The second is the weather files. So here you can see that I have chosen the location of Noida, and my software by myself, by using the AI technology, has chosen the Faridabad, has gone to the Faridabad weather station and choose that file. So what our software does is it goes to the nearest weather station from the site, uploads the weather files of Meteornom 7.3. So Meteornom 7.3 is the latest version of the weather files. Meteornom is the weather dataset, and these weather dataset is being used by 90% of the all the solar softwares and are most popular around the world. So we provide the weather dataset of Meteornom for all the location in the India and all around the world by default to our customers. But if any customer is not satisfied and he or she wants to just upload his or own weather files, he or she is always welcome. We have made a software which is controlled by you. You are not controlled by this software. So you can choose Solar GIS, 3DI, NREL, whatever you want. You can choose the source and you can upload your own weather files. But as of default, I will go for the Meteornom 7.3 only. The next is the client requirements. So here I will be putting some client requirements, like what is the unit, whether if I go into the edit and show you better. So depending whether my state discount provide net metering or gross metering, I can choose any metering type, and I give an average monthly consumption that I can see from the bill of my customer. And for example, if I hit a 35,000 units per month as my consumption, with an average unit of 7 rupees per 7 rupees per unit as my average cost, and give a tariff escalation rate of 4%. Now many of you might be knowing the two of the terms that I've used. The third term, the tariff escalation rate, means is that usually the life of a solar plant ranges from 20 to 25 years, and in that time, the solar discounts will not be charging us 7 rupees. There will be some inflation, some profiting over there. And that's why they will increase the price every year. So as of now, I have taken that after every year, they will be increasing the price by 4% as an average. And if I hit confirm, all these data will help me in doing the financial analysis and calculating the payback period. Now, if I just can move it. Okay. So here you can see there's a design plus option. So after designs, if I click on this plus, so this helps me as a designer, as an engineer, to give options to my customer, to my end customer. Sometimes the end customers want different things. They want to install different types of solar plant of different companies. Like for example, if I want to install a solar panel of Tata Power of 400 watt, the length will be different, the finances will be different, the generation will be different. Pardon me, but if you can just give me a minute, I need to mute myself. Sorry. Now I should continue. As I was telling, if we are Tata Power, we are using Tata Power panels of 400 watt, the generation will be different, the finances will be different. Then if I'm using a Vari panel of 300 watt, the length there also will be different, and so the financial will be different. So if I want to provide different designs type to my customer, I can make n number of designs of the same project just by clicking on this plus sign. So that helps the customer a lot to give to choose depending on his finances, depending on the generation he or she wants. So to create a design, I can give a name of say D1, and I can choose a default profile of let me choose demo profile. I will also tell you what this profile means. So if I hit confirm, so here you can see we are in the design summary page, and here if you follow my cursor, here clicking on this, I will be reached to the studio. So this is where all the magic happens. This is where I will be designing all the things, and as I will be using the tool on the left hand side to aid me in designing, and as I will be designing, the parameters on the right hand side will be changing. So to start my designing, I can go on to the polygon on the left hand side on the model and choose polygon. So we can have two options to design a site. Either we can go around the edges as I'm doing over here, or if I know the dimensions, I have visited the site and I know the dimensions, then I can simply hit my tab key, and in the tab key I can give any dimensions what I want. Suppose if I want a dimension of 54.28, I can just type it and hit enter. And here you can see that my whole design is completed. Now on the right hand side, I can change the different parameters. I can change the height, give it a parapet, and also different things. So let me give it a height. Now here you can see that by the shadow analysis and by the number of windows on the panels, I can, without going on to site, I can guess that this site is of 12-meter height, 3-floor building, and the height will be of 12 meter. So I can just hit a 12-meter height. And here I will give it a parapet height of say 1 meter. So generally in India, the parapet height ranges from 0.8 to 1 meter. So I can keep a parapet height of 1 meter with a parapet thickness of 0.30. And here if I zoom in a little bit on the design, so you will be seeing that after and before this white line, there is some blue region. So this is the setback inside and this is the setback outside. Generally, it is a practice that when an EPC player or when we install the solar panels, we leave some space around the edges for the safety as well as for easy access of the whole building, of the whole roof. So we are providing this region so as to visualize you that when we will be placing panels, no panel will be placed in this dark blue. No panel will be placed in this dark blue region, and I can change the setback inside and setback outside also. As I have previously told you that this software doesn't controls you, you controls the software, and so everything in it is editable according to your wish. So if I want to keep a setback inside of 0.2 meter and a setback outside of 0.1 meter, now you will see that the blue region has shrunk, and now in this region no panels will be placed. So I can better keep this setback inside of 0.4 to make it more realistic. And now you can see we have got a parapet also, and now you can see that there are some bumpties and cabins also on the roof. So I can draw these bumpties and cabins also, but first of all I will like to show you how the building will be looking like in 3D. So this is a rough building, how it will be looking like in 3D. You can see that there are no objects. We draw in 2D, and our software, by using the AI tools, have converted it into a 3D building. So that's how easy it is to draw on our software. Now if I have to draw the mumties and cabins also, I can just go and choose the polygon, or I can simply press the alphabetical P key as a shortcut key, go around the edges again, or if I know the dimensions, I can hit the dimensions also. So here I am around the edges. I have completed this design. I can similarly do it for other three mumties and cabins also. I can change the height individually also. So if I want to change the height from 2 to 2.5 meter, I can do it. Let me keep it as 1 meter only, as this is the outdoor unit of HVAC, outdoor unit of AC. Similarly, I can draw it like this. And here you can see that there's some cylindrical objects also. These cylindrical objects are cylindrical water tanks, which are very common in our residential buildings. So what I can do, I can simply go on the model on the left hand side, and here I can choose the cylindrical option. So here, wherever I wish to draw a cylinder, I go on to the center, hit my mouse key and give it any radius. So to give any radius, I can simply scroll my mouse and give it any radius, whatever I want. Or I can go and hit the tab key on my keyboard, and suppose I want a radius of 0.7 meters, so I can give 0.7 meter of radius and a point height of 2 meter, and here we are done. Now you can see that there's another object over here. I don't need to do all of these things again and waste my time. I can simply Control C, Control V copy paste it, that is use the control C and control V command, the same command that we use in our Word documents or in our general life in computer. And here you can see a copy has been made and it's on my wish where I want to place the object. Now here you can see that on the red line some parameters are also shown. So here this is telling me what's the distance between this object and this object. So here I can here I can decide at which distance I want my objects to be there. So either I can hit the tab key. So if I want a give distance of 3 meters, I can do it. Now this is how your roof will be looking like in 3D with different objects, cabins, mumties, HVAC, all of these things done within a span of 10 minutes or 5 minutes. That's how it's easy to draw on our platform. Again, now you must all be wondering that whether should we all provide the data or the parameters only in meters only. So that will not be the case. If I go on to the left hand side, bottom left hand side into the design settings, so here I have an option also whether I want to use my dimensions in feet and inches or whether I want my dimensions in meter, and I can hit save and that will do. Now I want to show you some of the features that are USP to this software. So if I click on the save button and on the bottom and on the left hand side, if you are able to see a sun shape icon, so on this sun shape icon, if I click on show, so this is a color coded map that we have generated by taking into account the sun hours of 365 days. So we have taken an average of all the sun hours throughout the years and then we have calculated and then we have generated this color coded map. This color coded map tells you the impact of the shadow, the impact of different objects on the roof, the shadow that they are creating. So here you can see that because of these objects and because of parapet walls, we are getting some shadow over here. So this, let me start. So here you can see that this bright yellow color is showing that here the roof will be getting a decent amount of air radiance and a little amount of shadow if is there. And here if I place the panels as an engineer, as a designer, I will be getting maximum generation. And as I go near to the objects, as you can see, we are getting somewhat light reddish region. This light reddish region shows that because of these objects, the height that we have provided, there's some impact of shadow on this roof. On the bottom roof, there's an impact of shadow. And because of this impact of shadow, we can place the panels over here as an engineer, because if we are having less space, we can go and place the panel in this light reddish region. But as we go nearer and nearer to the objects and we are getting into more violetish region and bluish region, here the impact of shadow is great. The irradiance is not of that much amount, and hence placing the panels over here will not be economical and will not be wise. Placing panels over here could create hotspot regions on the panels, which can lead to higher degradation of the panels. It can increase the maintenance cost, operation cost, as well as it can reduce the overall generation of the plant that you have calculated. So in that sense, on this green region and on this blue and on this yellow region, there is maximum radiation with no or little effect of shadow. As we move into the reddish region, we are getting into somewhat shadowish region. There is less irradiance, and more we are going into this darker bluish region, the impact of shadow is increasing. So now I will hide this feature, and now I will place the panels. So now I will like to tell you two, three ways in which you can place the panels on this particular software. So to place the panels, you can choose the roof where you want to place the panels, and on the right hand side you can choose the fill face option. By choosing the fill face option, the software, by using the AI technology, will place the maximum number of panels. And here you can see an optimum row spacing has been taken into consideration by the software. To calculate the row spacing by the software has taken into account the geolocation, the tilt, as well as the length of the solar panel and the climatic conditions. So I will tell you all about, I will describe each and everything in a minute. So here you will see on the right hand side, on the bottom right hand side, we have panel selection. So let me take a panel of say Tata of 500 watt. Okay, so there are no panels of Tata of 500 watt. So let me take Tata panels of 350 watt and hit space. Now, without going into the details of the AutoCAD, here I would like to just point out a fact to you that when you are using AutoCAD or any other software that are generally present in the market, you have to design the length, you have to see the spec sheet, design each of the panel by taking into account the length, breadth, width, the weight, the generation, what's their structure type, whether they are monocrystalline, polycrystalline, and then you draw in a single panel, and then you make copies by doing Control C, Control V, and then you place panels. In this software, the different panels that are using by the that are generally used by the people are already being fed into the back end, and the general installer can simply choose the company, the watt, and if he or she goes into the hover his or her mouse onto this I key, they can see the maximum voltage, the cell type, whether they are monocrystalline, mono, poly, PERC, bifacial, number of cells in the panel, and choose any one of them. So if I choose say a 450 panel, and similarly we have different structure types also. So different structure types are provided by this software. So here you can see different structure types are default fixed tilt, parabola, low foundation tilt, Tata power structures, unirex structure, general blast structure, fixed tilt structure have been provided. So a designer can use any of those structures, these prefabricated structures, use them in their designs, and can show their customer for visualization only. Can visualize their customer, can show their customers how their roof will be looking once the installation is done in 2D as well as in 3D. So that brings that installs more confidence into the EPC player, the installer. It installs more confidence of the customer into them, and that's why the software has provided this feature. So if I choose the default fixed tilt, I can change the tilt also. So here we are in Noida, so I can choose the tilt of 17 degree. Similarly, I can change the table size also, as well as I can choose whether I want my orientation is landscape or portrait. Now they are in portrait. I can choose whether I want it in orientation as landscape or that. Now, generally in residential areas, it happens a lot that people are little bit worried that whether they will be having enough space for irrigational purposes on the roof or not, and that's why they want their mount height a little bit higher, so as that they can get some space to walk on their roof to do some irrigational activities, and that's why there's a mount height option also. I will be showing you that also in a minute. And here you can see that the row spacing coming as of now is 1.073. Now, if I choose the tilt as 20 degree, just I'm changing the tilt, you can see that the row spacing itself has changed. Again, this software has a good thing that nothing is bounded on you, nothing is enforced on you. You can simply go into the manual and keep your own row spacing. But this is an optimum row spacing, and generally one should go with this row spacing so that the shadow of the front row do not falls on the panel, on the back row panels. So I will just hit update, and by showing you all of these things, now if I show you this in 3D, so this is how your roof will be looking like. This is a structure, and this is how your roof will be looking like. Now, if I show you another color coded map, which is a USP of this software only, on the left hand side below the heat map, we have the solar axis map. And again, if I go onto the show key, so now this map is also calculated on the same methodology that all the sun hours all around the year are taken into consideration. But instead of showing that what's the impact of shadow is there on the roof, this map tells you what's the impact of shadow and irradiance is going to be there on individual solar panels. So here you can see different types of panel, different colors. The dark green color, if you go on to the right hand side, you can see that when I am choosing this panel, the right hand side is showing us average solar excess of 99%. This 99% means that 99% of the time this individual solar panel that I have selected will be having no impact of shadow, and only 1% of the time throughout the year this individual panel will be having some impact of shadow. If I go into the lighter green, the solar excess is reduced to 97.8. If I go yet on lighter green, 96.1, 91.3, 77. That's too little, 87.2. So this is how the figures are coming as of now. Now let me do one thing. Let me increase the mount height now. So as of now, the mount height is coming as 1 meter. Let me change the mount height to say 2.5 meter, make it a little bit realistic. And if I hit update now, I go and save the design now. And now if I create the solar access map, so now here you can see that the panels that were coming in red, orange, whatever light red color, they have all gone, and now we are getting dark green colors with high solar access. That means that they are going to get a high solar radiance and low shadow impact. Now why has it happened? It happened because now if I show you in 3D, we have increased the mount height, and because of increasing the mount height, the impact of these objects, that these cabins, that because of these cabins some shadow were falling on the panels. Now all of this has been uh, there is no impact. We have increased the mount height, and that's why the solar axis has been increased, and that has increased the generation with the same panels. Now some of you, some intelligent people, and most of you will be wondering that these are so many legs over here, there is no space for the walking, and if I am going to show this roof to a customer, the customer will probably say no. And I totally agree with you. So that's why as of now what you are seeing is in one-to-one criteria, in one-to-one table. Now if I go and choose the table as 2 into 2 to make it again more realistic, I should not say realistic because in reality we use 3, 4 and so on depending on the space and depending on our installations. So if I choose a 2 into 2 now, so again my row spacing has increased, and now if I just go onto the solar axis map and refresh it again, okay, so we are getting somewhat of red panels over here also. So let me see what's the okay. So now if I go in auto, you can see that the row spacing has changed by double. I update it, save it, again made the solar axis map, refresh it. Again everything is good. The number of legs, now let us see what's the number of legs here. So the number of legs have reduced, we have more space for walking, and this is in general how your building will be looking like. So this gives you a holistic approach of how your building will be looking like. And as of them you can see that if I'm increasing the row spacing, decreasing the row spacing, the software is pretty much the dynamic software. Nothing in this software is hard coded. As you will be changing the parameters, you will be seeing that the generation is increasing, the DC size is increasing, and so forth and so on. So let me hide it as of now. If you have any doubt regarding the feature that I'm telling you, feel free to put it in the chat or in the question and answer box, and we will be answering them all at the end of the section. Feel free to post your questions over here. Now, some of you people must be involved in industrial and commercial projects only, and will be waiting for the shed roofs. So now the shed roofs, we can also draw the shed roofs on the software pretty easily. We can go around the edges, or if we know the dimensions, we can put the dimensions by using the tab key. Give it a base height of 10 meter, a tilt of 8 degree, a default tilt that usually in India the industry sheds have. The azimuth in this sense means that in which direction I want my roof to be tilted. So here you can see that there is a compass over here, and over here we have different angles, and here a arrow is there which is pointing in a particular direction. So here you can see that if I am choosing 57.58 degree as my angle, then my roof will be tilted in northeast direction. Similarly, this is southeast, southwest, and northwest. So I want my roof to be tilted as per my geometry in southwest direction. So I can simply choose this angle. I can hit update. And now there are some skylights and ventilators also. So for drawing the skylights, I can simply go and choose the polygon option. Simply do this, hit my enter key. On the right hand side, give it a base radius of 0.8 meter, 0.1 meter with the same tilt and the same azimuth, and hit update. And now you will be seeing that there are some exhaust fans also that are very typical in the industrial roofs. So for drawing them, we can go and simply choose the cylindrical option that we have in a model key, or simply press C key, alphabetical C key. That's a shortcut key for choosing the cylinder. Go to the center of the cylinder and give it any radius. So let me give it a radius of 0.4 meter with a height of 1 meter. That's a realistic height, and hit update. So you can see that there's a lot of exhaust fans on this roof. Drawing them again and again will be a very tedious task, and copy pasting them will also be a very tedious task. So what we can do, we can save our energy, our time. We can choose the object, Control C, Control V, make a single copy, click on the alphabetical R key on a keyboard, and now the software will be asking me how many copies I want. So if I just move this there, so here you can see my software asking for the repeat count, and now here I can see that I want 1, 2, 3, 4. I want 4 copies of it, so I can simply click 4. Now you can see 4 objects have been formed. So let me put it back to its place, and now if I zoom it a little bit, so here you will be seeing that there are 4 objects again, and I can place it wherever I want. It's according to my wish. If I want, I can drag one of them and I can move them individually also. So let me move it a little bit to its left, and now it's fine. Similarly, let me move this also a little bit to its left. And now if I show you in 3D, the half of the shed roof will be looking like this. Now, generally the shed roofs are symmetrical in shape. So I don't have to draw it again. I don't have to draw the whole structure again, do all of these things again. What I can do is I can choose the roof. I can hit my Control C, Control V command. That will make a copy of the roof. And now if I hit the alphabetical M key on my keyboard, the software will be asking to choose an edge about which I want to mirror the object. So I can choose this edge, I can move it here, I can place it here, and to show you this is how your roof will be looking like, the shed roof will be looking like, this is how your whole plant will be looking like. And now to place the panels, I can choose fill face over here. That will place the maximum number of panels. I can choose the fill face over here also. But let me show you another way of placing the panels. If I go and hit the undo key, and on the left hand side I go into the panel, and I go into this add subarray. Now many times it happens that a person don't want to cover his or her full roof. They only want to cover a particular section of the roof. So we can use this option to cover a particular section of the roof only. So suppose I want to cover only this portion of the roof. I want to place the panel only in this portion of my roof. I can just go over here. I can make it, and now only in that portion the panels have been placed. I can again choose the panel type, panel make. A particular row spacing has been chosen, and as of now the panels are oriented in due south direction. Now if I want, I can make them orient in any direction I want. So if I want it to be parallel to the wall, I can go on to the azimuth, and here I can choose the southwest southeast direction and hit update. And now you will be seeing that the panels are placed parallel to the roof. So you can see they are placed parallel to the roof. And now if I generate the solar axis map and see how my generation would be. So here you can see the generation is coming like this. The Average solar access is coming as good as 93.4, and in some solar panels as 94 also. So that's good. But is it to its best of its capability? So the answer is no. So if I go into the sub array, and now if I keep my azimuth as 180 degree, so the 180 degree, when we keep our panels in 180 degree, then we get the maximum solar radiance. And now if I hit update, save the design, go onto the solar axis and refresh my design. So now you will be seeing that the solar axis has improved a little bit. So now the solar axis is coming as 98.5, 98, 90.9. So that's a lot better than what we are getting before. So the software helps you in that thing also. Now suppose, let me show you one more thing. Now suppose if I choose here this sub array, so on my right hand side you can see that the size of only this roof, the half of the roof, the DC power that this is producing is coming as 108 kilowatt, and the number of panels that they're using is 343. Now suppose that the customer that you're designing the plant only wants a plant of 90 kilowatt. So what you can do, you can go onto the optimize, and here on the solar axis threshold on the subarray size, you can hit 90. And when I hit enter, so you will be seeing that all the solar panels that were not performing that good and were not needed to produce a DC size of 90 kilowatt have been removed by the software by itself. And in that sense, if I move this bar a little bit on my left, you will be seeing that the solar axis threshold is increasing, but the sub-array size and the total module quantity is decreasing simultaneously. If I move on to the right, the solar axis threshold is decreasing, and vice versa. So in that sense, as an engineer, as a designer, I can decide what sub-array I want, what solar axis threshold I want. That as a designer, I can choose that I will not be placing any panels that is getting an impact of more than 10% time throughout the year. So I can do any of these things, and I can close it also. So these are some of the features of the softwares when it comes to the designing. Now some more features, so as to give you a slide view. Generally what happens in the flush mounted roof is that for the axis and for safety reasons, the people place walkways, safety line and handrails. So what we can do, we have all those options in the software. So if I go and choose the walkway, in industry we have a standard that we will be placing the walkway after every 3 rows. So let me hide this map first. Go on to the model, choose the walkway, and after say after these 2 rows of panel, I want to place a walkway. And choose the walkway like this. Now I can change the parameters of the walkway also. On my right hand side, I can change the core height as well as the width. As of now, the height is 0.1 meters and the width is 0.25 meters, but I am free to change it. Now I can place the safety lines also. These are generally provided for safety purposes of the worker who is going there for cleaning purposes or for operation and maintenance. So suppose I want my safety line till here only, and similarly I can place the handrail also. So I can place the handrails. You can also place the handrails on the RCC roof. So generally what is happening nowadays is that instead of a whole opaque parapet wall, people like to install a small parapet wall of 0.1, a parapet height of 0.1 or 0.2 meter, and then give a railing and then install the railings. So it is over here. This is how it's happening. And now if I go onto the right hand side and choose the sun simulation, so on today's date at this time, the roof will be looking like this. That is on 26th August at around 5:45 p.m. The roof is looking like this. but I can see that how my plant is generating shadow all around the year on any time. So if today I want to see for 2 p.m. and now if I play this button, then for every day you can see that the days are increasing, and by this you can see for any particular time, for any particular day, how the generation is going to be there and how it will impact. Now I will let you settle it in your mind for the whole year. Let me give it back and play it. See how the roof is increasing. So this is how you are getting generation. So here you can see in the months of winter, the shadow length is increasing, and this is how we are getting the shadow all around the year at around 2:30 p.m. You can do this analysis for any day, for any time, through for any particular month or particular season. You can do it for like this. So in this this ends the all the generation part. Now here we can place the inverters also. So if I go on to the left hand side and choose all the components in the inverter menu, on the bottom right hand side I choose add inverter. So as they were having an inventory of solar panels, so they are having an inventory of solar inverters. So here if I choose ABB, here if I see that the DC size is coming as 315 kilowatts, so I will be choosing my inverters in that sense only. So if I choose inverters of ABB, and hit the search bar, so here you can see that the ABB inverters of all sizes I can see 30 kilowatt, 50 kilowatt, 120 kilowatt. So if I want to place inverter of 100 kilowatt only, I can keep my size as 100. And here if I hover my key on the I option, I can see the maximum MPPT voltage, number of MPPTs, input per MPPTs, string inverters, whether they are string, whether they are central inverters, and so on. So here if I choose this inverter of PVS 100 TL, so this is the inverter, and I can place the inverter wherever I want. So suppose I want to place one of my inverter over here, one over here, and one over here in the shady region, and hit enter. So I can change their orientation also. Suppose I want to change the orientation and keep it as 110, updated. Let me keep it at 130, updated. Yeah, so it has become somewhat parallel. I can scroll and place my inverter over here. Similarly, I can go over here and suppose I want to keep it at 70 degree. I can choose the change the mount height also. Suppose I want a mount height of 0.8 meter only, and if I hit update, I can go and do it like this. And this is how your roof will be looking in 3D. So this is your inverter. Finally, your roof is looking like this. These are your handrails. These are your walkway, the safety line. And if I show you one good thing about the software, so if I open the sun simulation and suppose like I'm doing this, so here you can see that even the shadow generated by this safety line is taken into consideration and can be visualized in here. So in that sense, even this even the impact of the safety line on the generation will be calculated by the software. So that's a good thing about the software. and uh, this is all about the designing. So I would wait for some time for you people to ask some questions if you want on the designing section, and if there are no questions, then we will be moving towards the report section then. I'm not able to copy and paste. Okay, so that's a different scenario. Actually, I have a small video of yours, so I will be sending you that thing. Or you can simply go over here and you can go to the site settings and give permission to the clipboard. So here you can see that I have allowed my clipboard. I have given my permission to the clipboard. Similarly, you can go to the site settings and allow your site to copy and paste. So that will allow the clipboard option. This is a long question. Okay, that's somewhat answering how pitch can be calculated to minimize the shading losses from other array and strings. Can you please explain me what do you mean by pitch, Mr. Lalit Rawat? I will be waiting for your reply if Lalit Rawat is here. Okay, and okay, so there are no more questions. So let me then save the design. And if I go on to the bottom right hand side, so here you can see that the load ratio is coming as 1.05. The AC size is 300 kilowatt, the DC size is 315 kilowatt. And now in the bottom right hand side, if I choose to calculate generation, then my generation, annual generation, specific generation, performance issue would be calculated. Okay, I have a chat, so take the poll. So here you can see the annual generation, the specific generation, and the performance issue for the whole plant has been calculated. And here if I hover my key on the I key again, then I can see that what are the different losses that have been incurred by my plant and I have taken into consideration. So the software takes into consideration the near shading losses, global irradiance, horizontal losses, soiling irradiance, and all of these losses. And you can see that whether the losses are under a limit or not. So here, if I go onto the bottom right hand side, bottom left hand side on the design settings, so onto the design settings, and if I go onto the losses section, so in the losses section, I can see that they are here. We have mentioned all the losses that is being taken into account by the software. So we have soiling loss, mismatch loss, LID loss, DC ohmic loss, AC ohmic loss, availability loss, module degradation rate, and the inverter efficiency loss. So I think so. I have covered this topic of the losses in one of my previous webinars. So you can go onto a YouTube channel, on the Solar Labs YouTube channel, and you can see. And if we have not covered it, for by instance we have not uploaded it, then we can have a next session of the losses only, in which we can talk about the losses, what are the different losses, and how we can minimize or how the losses affect our production. Is AC losses considered as default by software, and what should be the performance issue for good system? So that's a good question, Mr. Lalit. So AC losses is considered as default by the software. You are right in that thing. So here you can see, if I again go into the losses section, so here you can see that the AC ohmic losses and the inverter efficiency losses are taken, a generic figure has been taken. So generally, when we are installing a plant, if there is a normal plant, then the AC ohmic losses comes about 1% and the inverter efficiency losses come about 97-98%. So that's why a generic figure has been taken. But again, as I've told you, the software doesn't bind you in everything. If you want, you can change the AC ohmic losses also. So as it's happened in all other softwares also, we can change the different losses. So suppose I want to keep my AC ohmic losses as 1.3 or 1.4%. I can put it here, and similarly I can change my inverter efficiency also. So all of these things that I will be changing here will impact my generation all over the years, all as I'm moving further into my years in the finances also, and in my annual production specific generation PR also. Coming to the second part about the PR. So generally in India, the PR of 75, about 75 is taken as a good PR. Uh, a PR above 75 is taken as a good PR. So if your plant is producing, is giving a PR of 76 or 77, that means that the plant is in, that the generation is good, and that will give you more generation and can reduce your, what should I say, the payback period will be reduced. Yeah. The period will be reduced, and an optimum design has been created by you. So any other question, please post it on the chat box and I will be happy to take it forward and resolve your queries. And if there is any choice also, then we can, you can just type it on this chat box, or we can have a poll also for choosing the webinar topic for the next week. But you are welcome for telling us new topics that you want us webinars or web master classes for the next to next week or afterwards. Okay, so as of now we have calculated the generation. These are the various losses, and now if I save it and go on to this D1, then I will be directed back to the design summary page. And here, if you have noticed it before, then this page was totally empty. There was nothing here, but now since we have designed it, this we have filled it. We have DC size, we have AC size over here, the performance ratio, the DC by AC ratio, and the specific generation. So here the DC by AC ratio is 1.05. Generally, it's a practice in industry that we keep the DC by AC, DC to AC ratio, that is a load ratio, between 1.1 to 1.3, so as to reduce the mismatch losses in the plant. And also a small overloading has been done, because generally the plant does not produce the same DC size always, and that's why a DC by AC ratio of 1.1 to 1.3 has been taken. As of now I haven't taken a 1.05 as my DC by AC ratio. So this is the generation. Here you can see that I have told you that the weather file that I have put up, that we have uploaded, have helped us to calculate the generation. And you can see that depend on the climatic conditions, as we are increasing and moving to the summer season in the March, April, May, the generation is increasing. From March to April, January, February, March, April, the generation is increasing. In May, it has reduced a little bit, and as we are reaching into the monsoon season, that's the June, July, August season, the generation has reduced drastically as compared to the April's generation. And then again in October, the generation has improved a little bit on account of the autumn season, and again due to the winter season, the generation has reduced. These are the loss analysis that we have done. Now this is the bill of materials. So now here you can see that the different modules that we have used, their quantity have been put over here, their make, the company that we have used. Automatically the bill of material has been updated. The handle length that we have used, the walkway length that we have used, the inverter quantity, and the make that we have used, as well as the safety line, all of these has been added into the bill of materials. And all of this bill of material will be reflected into the report. So that's a good thing about the software, that the bill of material, we don't have to see it. Once we have designed, all the bill of materials that we have taken into account will be put into the bill of materials, and that will be reflected into the report. Now if someone wants to add some other component also in the bill of materials, for example DC cable, or for example tees, so if I give it a make of XYZ and give a hypothetical quantity of say 7, and I hit add, now I will be pointing out to you in the report that how it has been added into the report also in the bill of materials. In the next, we have the design. We have the pricing option. This is the last thing that we need to add. Now, generally in India, we the EPC installers take a charge their customers depending on the per kilowatt basis. And suppose if I choose a per kilowatt of 38,000 rupees for per kilowatt, reduce the taxation to 0, the discount rate to 0, and update it. Now you can see, depending whether you want your subsidy, if the state government or the central government provide any subsidy to you. So whether it provide you in percentage terms or in absolute terms, you can edit it over here, and you can put it. That will also be taken into account for calculating financial analysis. Now if I hit confirm, here you can see that the payback period is coming as 3 years 11 months. The LCOE is coming as 1.22, IRR of 28.13, and so on. Now if I download the report for now, here you can see that that the software provides a report which is of 16 to 17 pages. This is a lengthy report, and that's why they have provided an option that you can untake it, the pages that you don't want to download. So suppose you don't want to download the about us page, you can just simply untake it. But for as of now, to show you all the different features of the report also, let me keep them all ticked and hit confirm. Similarly, you can download the CAD layout also. So as I have told you that you can download the CAD layout as well as the SLD layout. So you can download that also. That is automatically generated by the software. In the meanwhile, do you have any doubt? Feel free to post it in the chat box. And now if I download the CAD layout also, and let me give it webinar as a name and hit save. Let me open AutoCAD line viewer, enter it. Upload new file, select file, and choose it. Now let me show you the report. So here, as I have told you, on the first page we have the project name as well as the client name. Now you can go onto the YouTube. This is a totally different session, and you can see what are the different features of the reports are. So you can go and log into and just simply go onto the Solar Labs YouTube page, and you can see that what are the different features, how it can help you, how it can help your customer to know the generation, to increase an EPC player sales, and so forth and so on. So I will not be discussing the report as of now. I will show you different features. So this is impact on environment, thank you slide, losses, snapshot of heat map and solar excess map, shadow analysis. This is the monthly table. This table is required if your end customer is going for sanctioning a loan. Then the banks will be asking for this particular slide of the presentation. In this presentation, the bank will be seeing that whether the customer will be able to repay their loan or not. They see it by seeing it, the global effective radiation that is coming on the roof, the E grade that the roof, that the plant will be given back to the grid, the specific generation performance issue. For knowing every parameter, please go onto the YouTube page and see for this report video. It's very detailedly described over there. Here you can see in the I have made promise that I will show you the T's. So I have added T's in my bill of materials, and that's reflected in my report also. So if I go on to the first page and click to view 3D model, so this will redirect me to the design that I have created. So if you are sending this PDF document, you download it in PDF and you send this PDF document to any of your customer. So your customer, by clicking on this link, can show how his or her roof is looking like, can do a dynamic sun simulation, that is shadow analysis, for any day, anytime, as well as see the important parameters also. You can share this link by itself to your customer. So let me try, and if I share this link on the chat box, so each one of you can go and see it on your own computer that how it's looking. You yourself can do the sun simulation and you can tell me your feedback on the chat box. So this is how it's looking. Now if I go onto the AutoCAD file that we have generated, so this is the CAD file that we have just designed. We designed in 2D. The software uses AI technology converted into 3D and gives us a automatic CAD layout. So this can be provided to the customer and it can help the customer, it can help the engineer to know how the panels are oriented, where to place the safety line. So here these are color coded. So the safety line is color coded in orange. The walkway is color coded in red. The handrail are color coded in brown. Panels in green, and fixed structures like this in dark blue region, dark blue color. Now here a designer can go, and if I just move it a little bit, so here if I go into the measure and I want to measure the distance between this and this building, I can do this also. So all of these features will be provided by the software. So this is in short how the software is, what are the different parameters that you can change on the software. And today we have learned one of the solar software, the Solar Labs. Now all of you are welcome to ask questions. If they are having any queries, you can ask your queries. You can post in the question and answer section, the chat section, and I will be very happy to resolve those things for you. So let me start a poll again and do this. So, okay. All of you can tell me also what choice do you want that I should do the next webinar on that choice also. Okay, so the first one is of increasing design efficiency of solar plant. Okay, for sure. All people are encouraged to just give their views. We will be very happy to do the master class on that topic on the next week. Okay, so it's decided. Uh, we will be having, if I share the results also to you all. So these are the results. So we will be having a next master class on increasing design efficiency of solar plant. So we have got one vote. That's okay. So let us stop sharing it. So any more questions you want to ask, you want to raise any more questions, you are heartily welcome to raise them. And then we will be ending this master class. If you want, you can reach out to me also on ayush@thesolarlabs.com if you have any questions in the future. So let me just put it here. And we can have a one-to-one interaction also if you want, a one-to-one dialogue. And there we can discuss some of the features also of the software and any other thing regarding to the software or any of your concerns.